All right, so welcome everyone. And in this lesson, we'd like to go ahead with the further attributes and the sections of the density. And also, we'd like to talk about the important settings for the simulation rate scale, the emit in the substeps, utilization of the auto resize attributes, controlling the max resolutions, so on and so forth. Okay. Before we proceed to the main course of the action and the simulation, I would like to have a word with you regarding any of the fluid reaction. Like it is not necessary that you have to implement this kind of thing only for creating the explosions. It's a general principle of this, FX or the dynamics, especially in the case when you are dealing with a very frustrating kind of thing that is a fluid, because they are pretty much slow when it comes to the real action, when it comes to really a high detail kind of a thing. The best way to utilize the fluids and the dynamics or any system in the Maya, being it a modeling, being it texturing, anything, you must start with the blocking of the subject. The blocking of the subject is always required to be pretty little low res, not to be very low res, but like in this case, I have been given 60 as a basic start for that. You may could go for 60 to 80, or let's say 100 is not a problem. And then once you are happy with the motion of the fluids with respect to the timelines, just have some 5 6 kind of the play blast. Go along with the settings of your keyframes and all if you wish to have those. And then start working upon the shading sections. So once you're happy with the shading and all, then start appraise your fluids. Okay. So in this case, I do have the settings, you know, and it's also possible that I may gonna have to come back and to change some few settings. So I will be sharing the final file with you where I should have set all those parameters completely ready to go to simulate for the reaction. Okay, so this we did in the previous lesson, and now it's time to give some more key attributes to the main section, that is the fluid shape node. So the boundary I've set to the none and none for the x and z axis, and for the y I've given the minus y, so that if you're going to play the reaction, you should see that the fluid is still constant from the minus y axis, okay? And there's no boundations regarding the x and the z sections. And here in this case, we like to utilize the temperature attributes, okay? But I do note the fact that there isn't anything inside the temperature. So we could do one thing, that let's say we're gonna switch that off, because it may gonna impact the, or it may gonna let you confuse what is happening in the density. Okay, so let's just do one thing just for the let's say um, first we're gonna address these two important things: the density, velocity, and the turbulence also, and then we'd like to come back to the temperature. Okay, so moving forward, let me just roll that back. The boundary draw should be kept to the bounding box. We just don't need them. And let's just come to the dynamic simulation. So here we like to go for the damp. Let's say 1.5 is a good start for that, because as far as the frames start increasing, the per frame the damp will going to affect the value. Okay. Yeah, of course, the high detail solve will set to all the grids. Now, the most important thing is the substeps here. Substeps, solver quality, and I guess everything is important. So, okay, no problem. But first of all, let's concentrate on the substeps. This attribute is very, very important to remove any kind of the jitteriness, or you can say instability inside the fluids. The basic thing is that you set 1, that means every frame it has to calculate the fluids. You set to the 3, that means for per frame it has to calculate 3 times. Okay, substeps is kind of a general thing you're gonna see in the N solver also, nucleus dynamics also, which is gonna improve basically the way the physics carry inside the Maya. Okay, so it's basically the kind of calculation steps. That means if you're counting for something, and it may could be a possibility that you missed out something, if you increased the counting for 2 times or 3 times, so the more you count, the lesser will be the chances of the errors to come up. So in this case, we need to be uh, pretty much, uh, play a very important role, and we have to be, um, we like to give the key approximately 6 for the beginning of the reaction, so you can visualize that, once we just start creating the explosion, you could see that the particles are very, very fast moving, so it may could be the chances that the particle may could skip out. So just to avoid that, we are giving the 6 sub-steps in the beginning section. And let's just do one thing. We're going to switch off the disable mode, okay, so that I can drag the timeline. And let's say from 0 to 25, again, we're going to come back to, okay, so not 35, let's say at least 35. We're going to come back to the 3. I'm just taking the 30 because 25 or 30 because we're going to complete at least 1 second. So after the impact of the 1 second, the fluid will start getting, quite slow, pretty stable and all. Okay. So that's pretty much good. And for the solver quality, we like to go for the 60 or 50, whatever you like, because we require a little bit higher solver quality. This reaction is pretty much big and will need to have a lot of smart calculation of the density as well as the velocity. So that's why the solver quality is very important. The next attribute comes the simulation rate scale. This is a parameter very responsible for for creating the fast moving fluids or the slowdown of the overall reaction inside the fluid container. So obviously you may could think that the reaction will going to burst out in the beginning of the frame. So we could give for 2.5 and let's set the key. And this is very important, since I have tested so many times, so that's why I just know what to do. But for you, I want you to pay some more attention, or you may could go for some more guesswork so that you could understand what exactly is the utilizations of keying the simulation rate scale. So beginning with the 0, we're going to end that up approximately 25, I guess. Yep. And I like to go for 0.5 or let's say 0.25. Okay. Okay, let's do one thing. 0.27. Yeah, I think so. It's not a problem. 0.5, we're gonna do the job. And we're gonna set the key. Okay. It could be possible, like I may have to come back again and we'll set instead of 0.25 to maybe 0.5, depending on the play blast, which we're gonna get after setting all these attributes, all right? So not an issue. And now, since we're utilizing the substeps, we could also switch on the ambient and the substeps, because without them, it's no point to discuss about the substeps. Okay, coming back again, and now here inside the auto resize attribute, I would like to switch on the auto resize, absolutely, because at a resolution of 200 or 250, it will be very difficult for us to calculate the things, since there will going to be a lot of data. So I guess the auto resize is pretty much okay. And we also going to need to utilize the auto resize margin. It's basically how much the voxels being taken in the precautions while the fluids are moving. If you set that thing to 0, it may could be a possibility that the fluid will gonna touch the containers. However, since the version 2011 and 12, this has been drastically improved. But still, we don't need to take any chance. So let's say we'll like to begin with 10 as an auto resize margin. And one more important thing why I'm picking up the very huge values of the auto resize margin is that because once the fluids start moving, it also requires some space to evolve. Okay, if you do not, and you know what, if you do not use this auto resize margin with a bigger value, especially if you're dealing with a high speed fluids, the reaction will going to be different completely. I have a number of times experimented on that. If you do not switch on the auto resize, or if you don't use the auto resize, you have a very big container for the fluids. Obviously, the time will going to take place a lot, but your reaction will going to be very accurate. Okay, but here we just cannot afford to have the auto resize turned to off. So that's why I'm picking up the higher values of the auto resize margin. Let's say we're going to go for 12. In fact, I'm going to put the key, and let's say at the frame number 30 or maybe 35, we're going to come back to 3 only. Okay, otherwise setting the very high value of the auto resize margin is going to cost you a lot of RAM and processing. Okay, so I guess these values are pretty straightforward. Let me just gonna roll back the disable evaluation, and let me just gonna play. At least we should see what exactly is taking place. So this is completely okay, not a problem. We are giving room to the reaction, and you can see that the auto resize is doing a very good job. It's providing some more space to the voxels to evolve. All right, so we'll do one thing. We'll take a pause and come back to the next lesson so that we could be able to address the parameters of the density and all. Okay, so I'm stopping that.